AI is everywhere now, right? It's writing our emails, helping doctors. It's woven into just about everything. And that brings up a really, really important question. How do we make sure these incredibly powerful systems don't go off the rails? How do we find their blind spots before they cause some real problems out in the world? Well, the answer is a super interesting field called AI red teaming. So here's what we're going to get into. We'll start with the absolute basics. What even is AI red teaming? Then we'll dig into why this kind of stress testing is so incredibly important. We'll peek inside the red teamer's toolkit to see how it's actually done, see what this new field can learn from its older sibling, cybersecurity, and then we'll look ahead at the future of AI safety.
All right, first things first. What exactly are we talking about when we say AI red teaming?
At its heart, red teaming is all about tackling this one massive question. Think about it. If we build these super complex systems and just let them loose without poking them to see where they break, we're not just being a little careless. We are taking a huge, huge risk. The solution? You have to think like an attacker. AI red teaming is basically a form of ethical hacking. But, and this is the important part, they're not trying to crash servers or steal passwords. They are targeting the AI's behavior. They're trying to manipulate its logic to see if they can trick it into doing something harmful or biased, something it was specifically built not to do.
So let's get into why this isn't just a nice to have. As AI gets more and more powerful, this kind of testing becomes an absolute must.
And here's the bottom line. For all the amazing things these models can do, they are not perfect. Far from it. They can be manipulated. Without someone intentionally trying to break them, they can be pushed into generating very convincing misinformation, spitting out toxic language, or even leaking private data. And that can have some serious consequences.
And hey, don't just take my word for it. Experts at places like Carnegie Mellon are essentially shouting this from the rooftops. As we start using AI for really critical stuff, think finance, healthcare, having these strict, methodical testing processes becomes completely non-negotiable. It's all about safety and trust. Okay, so how do you actually break an AI? This is where it gets really fun. It's less about writing code and a lot more about being clever with words, psychology, and logic.
A huge part of the job is something called advanced prompt engineering. Basically, red teamers are masters at crafting very specific inputs, prompts, that are designed to find loopholes in the AI safety rules. The ultimate goal is what they call a jailbreak, where they trick the model into completely ignoring its own safety programming.
One of the basic techniques is called role prompting. You just give the AI a character to play. It could be a sarcastic comedian or a cynical history professor. Now, that sounds harmless, right? But it's actually a really powerful way to test the model's boundaries. Can forcing it to adopt a persona make it bend the rules on what's appropriate or accurate in ways the developers never saw coming? And this is a great way to visualize how they test the AI's actual thinking process. On the left, you've got a simple chain of thought. That's the AI following one straight line of logic to get to an answer. But a red teamer might use a method like tree of thoughts, which you see on the right. That forces the AI to explore all these different branching paths at the same time. It's like a stress test for its brain. The more options it has to juggle, the more likely it is to get confused, make a mistake, or wander down a path it's not supposed to.
Okay, check this out. This is a fantastic, real-world example of a jailbreak attempt. This prompt is designed to fool an AI that sorts emails. See how clever it is? It's got this friendly tone, a sarcastic signature from Harry the hacker, but it also contains a very serious technical warning. The whole point is to confuse the AI, to make it focus on the casual vibe, and misclassify a critical security alert as not important. It's brilliant, really.
You have to remember, AI red teaming is still the new kid on the block. It's growing up fast, but to do that, it's looking for some wisdom from its much older, more established sibling, traditional cybersecurity.
And when you put the two side by side, you can really see the difference. Cyber red teaming on the left, it's mature, it's focused on things like software and networks, and it has all these standardized ways of doing things. AI red teaming on the right, it's still kind of in the Wild West, exploratory, focused on behavior. But the biggest difference is that last one, the threat model. AI red teams often don't have a clearer idea of who they're supposed to be defending against. Is it a sophisticated nation-state or just some bored troll on the internet? That really matters.
And this isn't just a hunch. The numbers are pretty shocking. A recent review looked at almost 100 different papers on AI red teaming.
Out of all of them, only 17, just 17, actually took the time to define what kind of threat they were testing for. That just goes to show you how much the field still needs to formalize its processes. But here's the good news. We don't have to reinvent the wheel. Cybersecurity has already created the blueprint. Things like adversary emulation, where you mimic a specific real-world attacker, and using standard playbooks and sharing open-source tools. That's the kind of rigor that can take AI red teaming to the next level.
So, what's the path forward? How does AI red teaming go from being a creative art form to a disciplined, reliable science?
Well, experts have pretty much laid out a 4-step roadmap. First, get serious about those realistic threat models. Second, look beyond just the chat box. The attack surface includes the training data, the user interface, everything. Third, start using the structured planning and reporting that cybersecurity teams use. And finally, number 4, develop standard tools and shared databases, like Jailbreak Bench, which is a public library of attacks, so that everyone can learn from each other and build stronger defenses together.
And all of this leads us to the final and maybe most important question. AI is moving at a dizzying speed. So the real challenge isn't just about finding the flaws we know about today. It's about building a safety system that's smart enough and fast enough to keep up with the AIs of tomorrow. It's a constant race, and our ability to stay one step ahead is what will ultimately define whether we get a future with safe, reliable, and trustworthy AI.